Hello class, and welcome to day 2 of section 1.7, and we are going to be covering absolute value inequalities. By the end of today's lesson, you will be able to solve inequalities that involve absolute values. So remember, absolute value is when we have something inside of those bars. There are going to be two types of absolute value inequalities. The first one is the AND case. This happens when you have something like the absolute value of x minus 3 is less than 4. So we've got a less than or a less than or equal to as part of our inequality. The other option would be if we have the absolute value of x minus 3 is greater than 4. So we have a greater than or equal to. The reason that absolute value inequalities are and or statements is because we have case 1 and case 2. So just like absolute value inequalities, the first way you solve it would be using the positive value, because positive 4 has an absolute value of 4, and the second case would have an absolute value of, or the absolute value is going to be the negative value. So it would be negative 4 is the answer for either of these. A crucial piece that you need to make sure you are paying attention to is when you do that second case and you set it equal to the negative value, you have to flip the inequality symbol. Because remember, when we multiply or divide by a negative, we have to flip the inequality symbol. So when we make it negative, we're multiplying by that negative, so we have to flip the inequality sign. Another thing that your book introduces in this section is interval notation. This is just a different way of writing out the answers to inequalities. This first option is what we call closed bracket notation, and this is for less than or equal to or greater than or equal to. This would be the equivalent of that filled in or closed circle on the graph. The second option is open, which is written with parentheses, and that's for less than or greater than, and that's the same as that open dot if you were graphing. If you have an AND statement, it's going to be written out as one interval. So for example, negative 7 and 8 in these squared brackets means negative x is greater than negative 7 and x is less than 8. So instead of writing out this long version of the answer, we can condense it using this interval notation. With the OR, it's written as two separate intervals, so this is something you have to pay attention to. With the OR, this first interval is always going to start with negative infinity with an open bracket. The reason being is that infinity goes on forever and ever, so we can't actually make that be an included value. It can't be equal to infinity, so it has to be an open parenthesis, or the open using the parenthesis for this first part. So we've got negative infinity to 1, this U, which there is a symbol in that on the online book that you'll be able to click on. This U stands for union, which means OR. And then this second part, we've got the open with 5 and then going all the way to a positive infinity. So this means, if we translate it into a traditional way of saying it, x is less than or equal to 1. So we have that equal to part on the 1. And it's less than or that going on forever. And then the OR part is x is greater than 5, so starting at 5 but not including it, so using that open bracket, and going all the way on to infinity. So we're going to solve and graph a couple very simple examples to start, and then we will move on to a few more complex ones. So this first one says the absolute value of x is less than 5. So I split it into case 1, which is x is less than 5. Nothing else to solve there. Because we start with a less than, we're going to make this an AND statement. And then our second part, we would say x is greater than negative 5. We made it the negative case, and we had to flip that inequality sign. There's nothing else to solve with either of those. So now I'm going to write it out into interval notation. So because I don't have that equal to part, it's going to be written in parentheses. My smaller value is negative 5, and my bigger value is positive 5. On the graph, your book also uses these parentheses or square brackets on the graph. So you would come to -5, 1, 2, 3, 4, -5, and put the parenthesis there, and then go to +5 and put the parenthesis there. So that's saying on the graph your answers are in between -5 and +5. If we come down to this second option, we've got x is greater than 5 to start. We're starting with greater than, which means we are in that or scenario. And then we want to say x is, we flip the inequality sign and make it a negative. Again, there's nothing additional to solve here, so we're going to want to go ahead and write this with our interval notation now. So when I do this, because it's an or, we're going to start with our lesser value. So we're going to say it goes from -infinity to -5. Both of those are open brackets because this does not have the equal to part. Then we're going to have that union or that u in the middle, and then we're going to start at 5 and go all the way up to infinity. So on the graph, this one would start with 1, 2, 3, 4, -5, and it's going this way to symbolize that everything less than or up until this parenthesis is part of our answer. And then we're going to go over 1, 2, 3, 4, +5, and that's the other parenthesis going that way to symbolize everything from 5 and greater is going to be part of our answer there. Getting into the more complex examples, we still have to pay attention to case 1 and case 2, but now we're going to have to do some additional solving because there's extra information inside the absolute value. So there's nothing outside, so I'm good to split it into case 1 and case 2. So case 1 is going to follow that 2n minus 18 is less than or equal to 2. Because we've got less than or equal to, it's going to be an AND statement. And then we've got case 2 is 2n minus 18 is greater than or equal to -2. Flipping the inequality sign, making the answer negative. So now we need to go through and solve these. My first step on both problems is going to be to add 18 to both sides. So as I am doing that, I've got 2n now is less than or equal to 20. And on this one, I've got 2n is greater than or equal to 16. My next step is going to be dividing by 2 on both sides of my inequalities. And I up with n is less than or equal to 10. And, because we've got an and statement here, n is greater than or equal to 8. Now you're going to want to make sure you write this in set notation. So when I do this, it's an and statement, so it's going to be written as one group. My smaller number is 8, comma, my bigger number is 10. And we are using square brackets this time because we have that greater than or equal to part on it. So on the graph, I'm going to come up and go all the way to 8 and put my first square bracket, and then go to 10 and put my second square bracket. So again, that's using the brackets instead of the points when we put it on the graph. Going through one more example before you'll try one on your own. We've got absolute value of 3x plus 3 is greater than 18. This one starts with the greater than. So I've got 3x plus 3 is greater than 18. Because it's greater than, it's going to be an OR statement. And we've got 3x plus 3 is less than negative 18. Again, flipping the inequality and making the second answer negative. As we solve, the first thing we need to do is subtract 3 from both sides of both inequalities. So we get 3x is greater than 15. And on this side, we have 3x is less than negative 21. My next step on both is going to be to divide by 3. So as I divide by 3 on all of these inequalities, I end up with x is greater than 5. And for the second one, x is less than negative 7. And these are an OR statement. So when I put this all together, I'm going to use my smaller value first. So I go from negative infinity to -7 with the open brackets on both because there's no equal sign, with the union, that u, going from 5 all the way up to positive infinity. On the graph, we come over to -7, and we've got our open bracket going to the left, and then we've got coming up to 5, open bracket going to the right. Go ahead and try this one on your own. When I solve here, my first step is subtracting 1 from both sides, and then dividing by 2 on both sides. This is a union case, an OR case, because we started with that greater than or equal to. And then when I graph, I've got negative infinity to -4. We've got that square bracket because of the equal to, the union, and then 2 all the way up to positive infinity, again with that square bracket. A couple of special cases with the absolute value inequalities. As I said with the equal or the equations, if it's equal to a negative, then it's a no solution. But with the inequalities, we have 2 possible options here. So we have the absolute value of 2n minus 5 is less than 3. We know absolute value has to be a positive number. Positive is less than -3. That's not possible, so we end up with no solution for this first example. If we come down to the second example, we've got a positive quantity, whatever that ends up being, is greater than -9. Any positive number is always greater than any negative number, so this ends up being an all solutions case. So to summarize, if the absolute value is greater than a negative, then it is all solutions. If an absolute value is less than a negative, then the answer is going to be no solutions. So these 2 special cases are involving if it has a negative as the answer portion. So the last thing we're going to do here is work on writing an inequality and then using it to solve. The debate team is traveling to a tournament and will spend 4 nights in a hotel. The cost for each team member must be within $20 of $175. Which of the pictured hotels can they consider? So if you remember from the absolute value equations portion of this lesson, we had x minus the middle is equal to the distance. In this case, it's not going to be equal to. We have to decide if it's going to be less than, greater than, less than or equal to, or greater than or equal to. So it's still going to follow the same formula, but instead of having an equal sign here, we have to determine which inequality symbol is going to go there. So some key pieces of information. We've got 4 nights. So we have to account for each of those nights. We have to be within $20 and then of 175. So in order to write my inequality, I'm going to start with the absolute value of, instead of just plain x in this case, we're spending 4 nights in the hotel, so it has to be 4x. The median cost there, that middle number that we have to be within, is $175. And then when it says within, we want to include $20, and we want to make sure that it's within, so that it's either $20 or closer than that. So we end up with the expression, the absolute value of 4x minus 175 is less than or equal to 20. Go ahead and solve this inequality on your own and determine which hotels are a viable option for them. Once we solve, we see that our price could be between $48.75 a night and $38.75 a night, which gives us that they could either choose Hotel A or Hotel B. If you have any questions about this or anything else from the lesson, please let me know when you get to class.